We're going to prove the law of sines. The law of sines say that in any triangle, the sine of angle A divided by little a, and the sine of B divided by little b, and the sine of C, angle C, divided by the side opposite C, they all have the same ratio. They're all equal. Kind of surprising, but they're all equal. Okay, so let us show this. Now, since angle A and B and the sides opposite them, they're no special than the sides of, or they're no special than angle B and the side opposite it, and angle C and the side opposite it. In other words, if I can show these two are equal, then by symmetry, these two are equal. And then by the transitive law, they're all three equal. So all I'm going to show is that these two are equal. So we take a triangle. We take an arbitrary triangle, A, B, and C. And this length is B, opposite angle C is little c, opposite angle A is length little a. And here I drop a perpendicular. I'll call this distance x. Well, since the whole distance is b, this piece here is going to be all of b less what I've already used up for the other piece. That is b minus x. And we'll call the hypotenuse h. And we look at things. What is the sine of A? The sine of A is opposite over the hypotenuse. The sine of A is x over c. And I guess I lied a little bit, but you'll see what I mean. The sine of C, now something's wrong here, I apologize. The sine of C, the sine of A is opposite A, which is h, over the hypotenuse C. And the sine of C is h over A. So now, what this tells me is solving for h is that h is equal to, let me write this equal. H is equal to c sine A. C sine A. And this tells me that h is A sine C. But since this and this both equal h, then these two things must be equal to one another. Well, I do have a typo. This clearly says c sine A, but I wrote A sine A. Now, if I divide both sides by AC, I maintain equality. The c's cancel out by design, and I'm left with sine of A divided by little a. And here the a's cancel out, and I have sine of C divided by little c. And the little lie I made was, I said that I was going to show this equals that. Sorry, I showed that this equals that. And by symmetry, I can show that A equals that sine A over A is equal to sine B over B. And if the first equals the third, and the first equals the second, then the second equals the third. That is, they're all equal. There is a proof of the law of sines. Nice and simple proof. So I should say now by symmetry we get that sine of b over b is equal to those two fractions. Just needs to be stated.